Hello Math 30-2 and welcome back to your second lesson in permutations and combinations. In this lesson here, we're going to learn about factorials, okay? So, we're going to start off here as I have a little secret, and the secret's about factorials. Let's see if you can figure out what that secret is. So on this side here, we have factorial representation. On this side here, we have an expanded factorial. So what does the factorial mean? So I'm looking at this here, we have 4 factorial. This is what 4 factorial looks like expanded. Here's 5 factorial. This is 5 factorial expanded. Okay? Let's take a look at this next one. There's 11 factorial. 11 factorial looks like this here. Oops. Put that back up. Somehow it got shot out of the way. Now let's look at the next one. It's 3 multiplied by 4 factorial. Do you have an idea of what that will look like? There. Now, I want you to pause the video and write down what you think my secret on factorials is. What is the definition of a factorial? What do factorials do? And then once you think you have it, come on back and we'll continue the lesson. So, here we go. Factorial notation. Factorial notation is normally set up like this here. Okay, that's the general form. So here's an example. If I said n was, let's say 10, then we're saying 10 factorial. So 10 factorial is the same as 10 multiplied by 10 subtract 1, multiplied by 10 subtract 2, multiplied by 10 subtract 3, and we're going to keep on doing this all the way till we get 3, 2, 1. Right? Well, let's see why it's like that. This here is going to be left at 10. 10 subtract 1 is 9. 10 subtract 2 is 8. 10 subtract 3 is 7. If we notice, it's exactly what the factorial notation is. We start counting down. 10, 9, 8, 7, all the way down to 3, 2, 1. Okay? So there is just an example. This here, we use n for general form. Okay? And where n must be a whole number. Okay? And it has to be positive. Alright. Let's take a look at this here. So n must be a whole number and it must be positive. That's a key thing to remember. This first one, it says, complete the following. N factorial is the same as, well, n, which is always, we start with the biggest term, and then we can multiply that by n minus 1, and then next would be, if it's factorial, we keep on taking away 1. Next is n minus 2, n minus 3, so on and so forth. Let's take a look at this next one. We have n plus 2 factorial. Well, what is one small, well, my first one's n plus 2. Now, what is one smaller than n plus 2? I'm going to say n plus 1 is one smaller. Okay? Then the next one will have to be n. Then n factorial keeps on going down. It'll be n minus 1, n minus 2. So notice how we start going down there, right? Because this is the biggest one, so the biggest one, then one smaller. Because if n is 10, this is 10 plus 2, which is 12, then 10 plus 1, which is 11, then 10, and then 9, 8, 7, 6, right? So it just would kind of look like that. So it's still going one smaller every time. Let's take a look at the next one here. We have n minus 4, n minus 5, n minus 6, then 3, 2, 1. Now, is this getting smaller? Yes. Why? Because if we said 10 minus 4, then the next one's 10 minus 5. This is the same as 6. This is 5. 10 minus 6 is 4. And we're keeping on going down to 3, 2, 1. So my biggest number is n minus 4. And we're keeping on going down by 1, so it's just n subtract 4 factorial. Okay, let's take a look at my next ones here. It says, simplify the following expressions. Leave the answers as a product where appropriate. All right, so the first one, we're always going to look at what is my biggest. There's 2 factorials, so we're going to look at which one's my bigger one and simplify that one and see what we can cancel off. N plus 2 is bigger than n. So let's take a look at it. We have n plus 2 multiplied by n plus 1 multiplied by n, and it's going to have to be n factorial. Right? Now I see this n factorial, that's right there, so I can stop there. And then we have n factorial on the bottom. these will cancel off. I'm left with n plus 2 multiplied by n plus 1. Okay? And that's it. Let's take a look at b. Which one of these is bigger? N minus 2 or n minus 1? Well, if n is 5, 5 minus 2 is 3. 5 minus 1 is 4. So actually, the denominator is bigger in this one, not the numerator. So I'm going to leave the numerator as is, n minus 2 factorial. Okay? So my denominator is n minus 1. And what's one smaller than n minus 1? N minus 2 factorial. Okay, because this still has to go on forever. These cancel off. I'm left with 1 over n subtract 1. All right, let's take a look at the next one. Now, I only have a factorial on the top. I don't have a factorial on the bottom. So, what am I going to do? For this one, I'm just going to start simplifying the top. So I have n. Okay, well, there's 1n. Then it'd be n minus 1 factorial. But I think I could go a bit more. N minus 1. And then I'm going to have n factorial. I stopped, or n minus 2. Ooh, factorial. Made a little mistake there. Clear it up. That's all going to be over n multiplied by n subtract 1. This and this will cancel off. Right? Now this and this here will cancel off. So I'm just going to be left with n subtract 2 factorial. Can't really put that as a product, separate products, because it could go on forever. We don't know how big n is. All right. Now the next one is algebraically solve this equation. All right. So let's take a look at this. I'm going to try and simplify first. Which is bigger, n or n minus 2? n is bigger than n minus 2. So we have n multiplied by n subtract 1, then multiplied by n subtract 2 factorial all over n subtract 2 factorial. So these could cancel off, and that's equal to 42. So I'm left with n multiplied by n subtract 1 is equal to 42. Now I could expand this out, so I'm going to get n squared minus n, and I'm going to move this 42 over there, so I get subtract 42 is equal to 0. Now this is a little nice here. It's just a perfect quadratic, because as soon as I look at this, it's quadratic, make it equal to 0. Now we use our box method to factor. Or you could use your trusted calculator, graph it, and find your zeros, or your x-intercepts. So I have negative 42, and I'm going to have negative 1. Now what multiplied by what gives us negative 42? 6 and 7. And we can say negative 1 when we add them together. The bigger one must be negative. So we have negative and positive, so 7 and 6. So we have n subtract 7, and we have n plus 6 is equal to 0. That means n subtract 7 is equal to 0, or n plus 6 is equal to 0. If I solve for this, plus 7 to both sides, I get n is equal to 7, and here I'm going to get n is equal to negative 6, because I subtract 6 from both sides. Now looking at, these two answers, which one could I use? Well, this one here is negative, so we can't really look at that. This one's positive. So this one's an out, so I'm going to be left with just n is equal to 7, because I can't use the negative. It would be going infinitely big on the negative forever. Okay? So once again, what I did for this one was I first canceled it down, so I ended up making kind of one side with my variables equal to the other. No more factorials. Then, since it was a quadratic, I had to factor. I used my box method. Then, with that box method, I was able to solve for each one, and I knew it could only be a positive and not a negative. Okay. So, let's take a look at this next one. We could also do factorial notation on a calculator, which can make things faster. So we're going to take, I'm going to use a note, take my trusted calculator here, and this first one wants us to do 43 factorial divided by 40 factorial. So we go on 43, and I'm going to go math factorial, okay, divided by 40. Math factorial. enter. That gives me 74046. Okay? Now, if I look at that, this is really 43 multiplied by 42 multiplied by 41. That could be fast for this one, which gives me the same answer. But if we look at this next one, it's a little bit more complicated. There's a lot more multiplication to do there. So let's try this one. I'm going to have to go 37, math, and we want factorial. And we're going to divide that all by, this is divided by all of this. So I'm going to have to put both of these in brackets in my calculator. Otherwise, if I just do this and I don't put in the brackets, it's going to go this divided by that, then multiply everything by that. So I have to put them both into brackets, okay? So I'm going to have 33, we're going to go math, and we go factorial, and then I'm going to multiply that by, what is it? 4 math, and we're going to go over to factorial, and close it, and I push enter, which will give me a total of 66,045. Okay? So there we go. Now we're going to look at permutations. We're going to just go over it a little bit here. Okay? So if we're looking at a word, like we did last class, we could use the fundamental counting principle, or we could do permutations. All right? So if I look at this word regina, we have 1, 2, 3, 4, 5, 6. So there's 1, 2, 3, 4, 5, 6. So that's 6 times 5 times 4 times 3 times 2 times 1. But we learned that this is the same as 6 factorial. Well, 6 factorial, I just put that in my calculator. It's so much faster. I just go 6 math over factorial, and I get 720. And that's it. It's a lot faster. So your calculator can help speed it up. Let's take a look at Kelowna. There's 1, 2, 3, 4, 5, 6, 7. So that is actually 7 factorial. So I'm going to put that into my calculator, and I'm going to go 7 math all the way over factorial, which is 5,040. Now our next little bit here, we're going to now get into something called more permutations with our formula. Okay, so our formula looks like this, and I'm going to just start showing you in the next equation. Okay, so here we go. Using the fundamental counting principle, we're going to try and solve this. So there are 2 different letters followed by 4 different digits if the letters I, O, Y, and Z are not used. So our first are 2 different letters. Okay, so we have 2 different letters, and since there's 26 letters in the alphabet, but we have 4 that we can't use, we're going to have 22 and 21, and they can't be repeated. Next, we're followed by 4 different digits. 1, 2, 3, 4. Okay? Now, 4 different digits. So if there's 4 different digits, we have a total of 10 to choose from, because 0 to 9, right? 0 to 9, and then we have one less, so it's 9, 8, 7. And I multiply all those together, I'm going to end up getting 22 multiplied by 21 multiplied by 10 multiplied by 8 multiplied by 7 multiplied by 6. Whoops, not 6. Delete, delete, push enter. I get 258720. Okay? Now the next one, we're going to look at our permutations. So we're going to use the permutation ring. So basically, if I look at this, I like to think of it as n pick a number. Okay? Also, anytime we do permutation 0, so 0 factorial, that is always equal to 1. It's not equal to 0, it's equal to 1. So we look at my formula here, it's n pick r. So if I go n pick r, so it's, think of it that way. So out of 24, or 26, sorry, out of 22, because we cannot choose these, so out of 22 options of letters, we are picking 2. Okay? Then we have, out of 10 options of numbers, we are picking 4. okay, because they can't be repeated. So I look at that here. I'm going to put that into my calculator and show you how we do it. I'm going to go 22, then I hit the math button. I'm going to go all the way over to this, and we pick 2. Enter. Then I'm going to multiply that by a bracket. We have 10, math, go all the way over, there, and we're picking 4. 10 permutation 4. Enter. Which gives me 2,300. Now, I'm looking at this, I have a different number there, which means I probably made a mistake somewhere here. So I'm going to try this again. 22 multiplied by 21, multiplied by 10, multiplied by 9, multiplied by 8, multiplied by 7. 1, 2, 3, 4. There we go. Now I get the same number. So I made a mistake there. It's easy to make a mistake punching in all those numbers in the calculator. It's easy to forget. 2, 3, 2, 8, 4, 8, 0. Okay? So there we go. That's done. And that's how we do it. So if we could see here, using the permutations could be a lot easier and a lot simpler. Okay? And another thing to remember is permutation or the factorial of 0 is always equal to 1. All right? So a way of thinking about that they have here is factorial of 0 is equal to 1 because if you have 12 and you want to pick all 12, how many different ways can you pick all 12? There's only one way. You take all 12. And that's it. Okay? Well, that's everything. Hopefully you understood. As I see you tomorrow, we'll work on this together.